Bitcoin addresses. A Bitcoin address is a string of digits and characters that can be shared with anyone who wants to send you money. Addresses produced from public keys consist of a string of numbers and letters, beginning with the digit 1. Here is an example of a Bitcoin address: 1J7MD OXZY. The Bitcoin address is what appears most commonly in a transaction as the recipient of the funds. If we compare a Bitcoin transaction to a paper check, the Bitcoin address is the beneficiary, which is what we write on the line after pay to the order of. On a paper check, that beneficiary can sometimes be the name of a bank account holder, but can also include corporations, institutions, or even cash. Because paper checks do not need to specify an account, but rather use an abstract name as the recipient of funds, they are very flexible payment instruments. Bitcoin transactions use a similar abstraction, the Bitcoin address, to make them very flexible. A Bitcoin address can represent the owner of a private public key pair, or it can represent something else, such as a payment script, as we will see in a future section. For now, let's examine the simple case, a Bitcoin address that represents and is derived from a public key. The Bitcoin address is derived from the public key through the use of one-way cryptographic hashing. A hashing algorithm, or simply hash algorithm, is a one-way function that produces a fingerprint or hash of an arbitrary sized input. Cryptographic hash functions are used extensively in Bitcoin, including in Bitcoin addresses, in script addresses, and in the mining proof-of-work algorithm. The algorithms used to make a Bitcoin address from a public key are the Secure Hash Algorithm (SHA) and the Race Integrity Primitives Evaluation Message Digest (RIPEMD). Specifically, SHA-256 and RIPEMD-160. Starting with the public key BitK, we compute the SHA-256 hash and then compute the RIPEMD-160 hash of the result, producing a 160-bit number. This resulting number is the Bitcoin address. Tip: a Bitcoin address is not the same as a public key. Bitcoin addresses are derived from a public key using a one-way function. Bitcoin addresses are almost always encoded as base 58 check, which uses 58 characters and a checksum to help human readability, avoid ambiguity, and protect against errors in address transcription and entry. Base 58 check is also used in many other ways in Bitcoin, whenever there is a need for a user to read and correctly transcribe a number, such as a Bitcoin address, a private key, an encrypted key, or a script hash. In the next section, we will examine the mechanics of base 58 check encoding and decoding and the resulting representations. Base 58 and base 58 check encoding. In order to represent long numbers in a compact way using fewer symbols, many computer systems use mixed alphanumeric representations with a base higher than 10. For example, whereas the traditional decimal system uses the 10 numerals 0 through 9, the hexadecimal system uses 16, with the letters A through F as the 6 additional symbols. A number represented in hexadecimal format is shorter than the equivalent decimal representations. Even more compact, base 64 representation uses 26 lowercase letters, 26 capital letters, 10 numerals, and 2 more characters, such as quotes and slash, to transmit binary data over text-based media such as email. Base 64 is most commonly used to add binary attachments to email. Base 58 is a text-based binary encoding format developed for use in Bitcoin and used in many other cryptocurrencies. It offers a balance between compact representation, readability, and error detection and prevention. Base 58 is a subset of base 64, using upper and lower case letters and numbers, but omitting some characters that are frequently mistaken for one another and can appear identical when displayed in certain fonts. Specifically, base 58 is space 64 without the number 0, capital O, lower L, capital I, and the symbols double left quote and slash. Or more simply, it is a set of lowercase and capital letters and numbers without the 4 just mentioned. To add extra security against typos or transcription errors, base 58 check is a base 54 encoding format frequently used in Bitcoin, which has a built-in error checking code. The checksum is an additional 4 bytes added to the end of the data that is being encoded. The checksum is derived from the hash of the encoded data and can therefore be used to detect and prevent transcription and typing errors. When presented with base 58 check code, the decoding software will calculate the checksum of the data and compare it to the checksum included in the code. If the two do not match, an error has been introduced and the base 58 check data is invalid. This prevents a mistyped Bitcoin address from being accepted by the wallet software as a valid destination, an error that would otherwise result in loss of funds. To convert data into a base 58 check format, we first add a prefix to the data, called the version byte, which serves to easily identify the type of data that is encoded. For example, in the case of a Bitcoin address, the prefix is 0, or 0x00 in hex, whereas the prefix used when encoding a private key is 128, or 0xx0 in hex. A list of common version prefixes is shown in the table below. Next, we compute the double SHA checksum, meaning we apply the SHA-256 hash algorithm twice on the previous result. From the resulting 32-byte hash, we take only the first 4 bytes. These 4 bytes serve as the error checking code or checksum. The checksum is concatenated to the end. The result is composed of 3 items: a prefix, the data, and a checksum. This result is encoded using the base 58 alphabet described previously. In Bitcoin, most of the data presented to the user is base 58 check encoded to make it compact, easy to read, and easy to detect errors. The version prefix in base 58 check encoding is used to create easily distinguishable formats, which when encoded in base 58 contain specific characters at the beginning of the base 58 check encoded payload. These characters make it easy for humans to identify the type of data that is encoded and how to use it. This is what differentiates, for example, a base 58 check encoded Bitcoin address that starts with a 1 from a base 58 check encoded private key WIF that starts with a 5. Some example version prefixes and the resulting base 58 characters are shown below. For a Bitcoin address, the version prefix and the base 58 result prefix are 0x00 and 1 respectively. For pay-to-script hash address, they are 0x05 and 3 respectively. For Bitcoin testnet address, they are 0x6f and M or N respectively. For private key WIF, there are 0x80 and 5K or L respectively. For BIP38 encrypted private key, there are 0x0142 and 6P respectively.